example 9 asks us to draw the following functions, where we have these different linear functions going on. So A gives us y equals the absolute value of x plus 3 minus 2. So what you have to understand is that an absolute value has to be positive. So, but it is based off of a normal graph. If we had the graph of, or excuse me, the A is the absolute value of x plus 3. So we want to graph x plus 3, or think about the graph of x plus 3 first. So this graph is going to, if we were to start, we have the graph of x plus 3. So this would have a y-intercept of 3, and we would have a graph that looks like this. Now, we're not allowed to have negative values in our absolute value. So what happens here is that instead of using this part here, which is negative, we reflect it over. So it's the same thing, but it's reflected up. And so that is the absolute value function. A lot of people think of it, it looks like a V, because it's, especially if it's of a line, because a line that can't be negative is just going to rebound once it is negative and become positive, so it'll make a hard point right there. So think about the line as if it was not an absolute value, and then only reflect the negative parts back over the exact same distance in the exact same way that it would have been the other way. Now B was the y equals the absolute value of x plus 3 minus 2. Okay, so if we look at this graph, now with this graph, the absolute value part, like from our previous problem, looked like this. Okay, now that's the absolute value, right? That's what that is. Now, this minus 2 up here is not in that range, right? What the negative 2 is doing is it is lowering all of our values by 2. So what we need to do is take this graph and lower it by 2. So the new graph would be everything is 2 lower. So that would be what this looks like, as opposed to the original, right? So this graph is allowed to be negative because of the minus 2 not being as part of the absolute value. But we have to respect what that absolute value can do. So you think about the original and what that negative 2 means. The negative 2 in the end is pulling the whole function down 2. With no effect otherwise. The absolute value remains the same, so we just take that same graph and drop it by 2 to get this graph. So just be careful that you don't take that 2 away from the 3 and call this like x plus 1 for whatever reason, because remember, it is locked in parentheses. It has different attributes than a normal positive 3 would have.